When dealing with a 2000 amp feeder that utilizes parallel conductors, determining the appropriate size of the equipment grounding conductor, or EG, is crucial for safety and code compliance. In this scenario, the feeder consists of 10 parallel runs, with each conduit containing 3/0 conductors per phase. According to the National Electrical Code, or NEC, the size of the equipment grounding conductor must be based on the size of the ungrounded conductors. Specifically, NEC Table 250.122 is used to determine the minimum size of the equipment grounding conductor for grounded systems. This table correlates the size of the ungrounded conductors or the overcurrent protective device with the minimum size of the copper or aluminum equipment grounding conductor. The requirement is to determine the equivalent size of the ungrounded conductors for the entire 2000 amp feeder. Since there are 10 parallel runs of 3/0 conductors per phase, you need to consider the ampacity of 10 3/0 conductors in parallel. The ampacity of a single 3/0 copper conductor, based on NEC Table 310.16, depends on the insulation type and the temperature rating. Assuming a common insulation type such as THHN, with a 75 degrees Celsius rating, a 3/0 copper conductor has an ampacity of 200 amps. Therefore, 10 parallel 3/0 copper conductors would have a combined ampacity of 2000 amps, which matches the feeder size. Now that you know the total ampacity of the ungrounded conductors is 2000 amps, you can use NEC Table 250.122 to determine the minimum size of the equipment grounding conductor. Looking at the table for a 2000 amp overcurrent protective device or equivalent conductor size, the minimum size of the equipment grounding conductor is 400 American wire gauge or AUG copper or 500 AWG aluminum. It is very important to use the correct NEC table. Using the wrong NEC table leads to incorrect calculations and an undersized or oversized equipment grounding conductor. Remember to always consult the latest edition of the NEC and to consult with a qualified electrical engineer or inspector to ensure compliance with all applicable codes and regulations. The equipment grounding conductor is a critical safety component of the electrical system. It provides a low impedance path for fault current to return to the source, which facilitates the operation of the overcurrent protective device such as a circuit breaker or fuse. This helps to quickly clear ground faults and reduce the risk of electrical shock or fire. Several factors must be considered when selecting the appropriate size of the equipment grounding conductor. Firstly, the size of the ungrounded conductors or the overcurrent protective device is the primary determinant. As previously mentioned, NEC Table 250.122 provides the minimum size requirements. Secondly, the material of the equipment grounding conductor, whether copper or aluminum, affects its ampacity and size. Copper has a higher ampacity than aluminum for the same size conductor, so an aluminum equipment grounding conductor will typically need to be larger than a copper one for the same application. Thirdly, the length of the equipment grounding conductor can also impact its size. Longer equipment grounding conductors have higher impedance, which can reduce their effectiveness. In some cases, it may be necessary to increase the size of the equipment grounding conductor to compensate for the increased impedance. Fourthly, the type of equipment grounding conductor installation also matters. Equipment grounding conductors can be installed in various ways, such as in the same raceway as the ungrounded conductors, or separately. The installation method can affect the equipment grounding conductor's ampacity and impedance. It is important to note that the equipment grounding conductor must be properly connected to the equipment and the grounding system. The connections must be made with approved connectors and must be tight and secure. Loose or corroded connections can increase the impedance of the equipment grounding conductor and reduce its effectiveness. In addition to the minimum size requirements specified in NEC Table 250.122, there may be other requirements that apply to equipment grounding conductors. For example, NEC Section 250.4 requires that equipment grounding conductors be installed in a manner that minimizes the risk of damage. This may require the equipment grounding conductors to be protected from physical damage, such as by installing them in conduit or other protective enclosures. NEC Section 250.130 outlines the requirements for equipment grounding conductor connections. This section specifies the types of connectors that are permitted to be used for equipment grounding conductor connections and the methods for making the connections. NEC Section 250.134 addresses the grounding of equipment connected by cord and plug. This section requires that cord and plug connected equipment be grounded through the equipment grounding conductor in the cord. It also specifies the types of cords and plugs that are permitted to be used for grounding. When working with electrical systems, it is important to follow all applicable safety precautions. This includes wearing appropriate personal protective equipment, or PPE, such as safety glasses, gloves, and hearing protection. It is also important to energize the circuit before working on it and to verify that the circuit is energized using a voltage tester. Understanding the NEC requirements for equipment grounding conductors is essential for ensuring the safety and reliability of electrical systems. By following the code requirements and best practices, you can help to protect people and property from the hazards of electricity. The specific size of the ungrounded conductors that you have is 3/0. So the first step is to calculate the total ampacity of the 10 parallel 3/0 conductors. Referring to NEC Table 310.16, we find the ampacity of a 3/0 copper conductor with THHN insulation rated at 75 degrees Celsius is 200 amps. Multiplying this by the number of parallel runs, which is 10, we get a total ampacity of 2000 amps. Now that we have the total ampacity of the ungrounded conductors, we can refer to NEC Table 250.122 to determine the minimum size of the equipment grounding conductor, or EG. According to NEC Table 250.122, for a 2000 amp overcurrent protective device or equivalent conductor size, the minimum size of the equipment grounding conductor is 400 AWG copper or 500 AWG aluminum. The NEC also provides requirements for the installation of equipment grounding conductors. Equipment grounding conductors must be installed in the same raceway or cable as the circuit conductors. This ensures that the impedance of the equipment grounding conductor is minimized, which is important for effective fault current flow. Equipment grounding conductors must be connected to the equipment grounding terminals of all equipment enclosures and devices. This provides a low impedance path for fault current to return to the source. Equipment grounding conductors must be sized and installed in accordance with the NEC to ensure that they can safely carry the available fault current. The available fault current is the amount of current that would flow in the event of a short circuit. Several factors can affect the available fault current, including the size of the transformer, the impedance of the conductors, and the distance from the transformer to the fault location. To determine the available fault current, you can use a fault current calculator or consult with a qualified electrical engineer. It is important to note that the equipment grounding conductor is not intended to carry normal circuit current. The equipment grounding conductor only carries current in the event of a fault. Therefore, it is important to ensure that the equipment grounding conductor is properly sized to carry the available fault current, but it is not necessary to oversize the equipment grounding conductor to carry normal circuit current. In addition to the NEC requirements for equipment grounding conductors, there may be other requirements that apply depending on the specific application. For example, some equipment may require a dedicated equipment grounding conductor. A dedicated equipment grounding conductor is a separate equipment grounding conductor that is run directly from the equipment to the grounding electrode system. Dedicated equipment grounding conductors are often used for sensitive electronic equipment to provide a low noise ground. Other equipment may require an isolated equipment grounding conductor. An isolated equipment grounding conductor is an equipment grounding conductor that is isolated from the building's grounding system. Isolated equipment grounding conductors are often used in hospitals and other healthcare facilities to protect patients from electrical shock. When selecting equipment grounding conductors, it is important to consider the following factors. Firstly, the size of the ungrounded conductors. Secondly, the available fault current. Thirdly, the type of equipment being grounded. Fourthly, the installation environment, and fifthly, any other applicable requirements. By considering these factors, you can ensure that you select the appropriate equipment grounding conductors for your application. Always consult with a qualified electrician or electrical engineer to ensure that your electrical system is properly designed and installed. Electrical safety is paramount.